Dah. Uh, Assalamualaikum and good afternoon. My name is Nur Afrina Balkis binti Zaidi and my friends Siti Aisyah binti Akram, Nur Syafinas binti Muhammad Fauzi, Purvendra anak lelaki Acutan and Ponara anak lelaki Kumara Rao. Today we wanna present about assignment 2, which is gear train design. What is gear train? Definition of gear train is combination of two or more gear that used to transmit power. And gear train is classified into four types. First is simple gear train, second compound gear train, and three riveted gear train, and the last one is epicyclic gear trains. Next, simple gear trains. When there is only one gear fitted on each shaft, then this type of gearing system named simple gear trains. Compound gear trains. When we need higher speed ratio or a much lower speed ratio, then we need to use compound gear trains. In this case, each intermediate shaft has two gears rigidly fixed to it. And due to both the gear fitted on the same shaft, we can see the same speed in both the gears. We can see the picture in the slide. Next, gear trains. In the case of the riveted gear train, the driver and the last gear are coaxial. We can see from the picture in the slide, the last gear are coaxial. And this type of arrangement is used in clocks and in simple lead where back gear are used to give a slow speed to the chuck. Next, we can see the epicycle gear train. The epicyclic gear train is useful to transmitting high velocity ratio with a gear of moderate size in less space. We use an epicyclic gear train in wristwatch. We can see at home, we use the epicyclic gear trains at a clock. We can see from the example. And next slide, my friend will continue. Aisyah?
Okay. Do you hear me?
Yeah, here.
For the moment, we need to complete one cases, which is as shown in the slide. A company required you to design a riveted gear train as shown in a figure below with a ratio of 12 and minimum number of gear teeth must be at least 24 teeth. In addition, it requests the gear train to strictly follow a standard series of modulus. Modulus of A and gear A and B need to be 3.125 millimeter, and for gear C and gear D are 2.5 millimeter. The first thing we need to find is we need to determine the suitable number of teeth on each gear in order to obtain a real speed ratio. So as we all know that the speed ratio that been given is 12 from gear A to gear D. And then for model A and B, 3.125 millimeter, model C and model D, 2.5 millimeter. These are the list of assumptions that I made to ease my calculation later. Next. Since the speed of ratio between gear A and B, between gear C and D are the same, therefore we conclude that NA over NB equal to NC over ND. And in the question, already given that the ratio is 12:1. So we're gonna find the speed ratio. So we square root the 12, we get 3.464. Any pair of gear in mesh is inverse of the number of their T. So we also inverse, that means we need to change the position. TB over TA equal to TD over TC equal to 3.464. From formula, we can know the distance between shaft as shown in the slide. Model A times TA plus model B times T equal to model C TC plus model D TD equal to 200. And then we're gonna put the value in the formula and we got the equation as shown. Okay, from equation 2, we can assume that TA plus TB equal to 400 divided by 3.125 equal to 128. That means TA plus TB equal to 128. And then we move to equation 3, 3C plus 3D divided equal to 400 divided by 2.5. We got 160. So from the equation 1, we substitute the value of TB in equation 2 and we gonna get the value of TA, which is 28. Next, we substitute the value of TA that we got from above to equation 2 and we're gonna get the value of TB. And again, we refer to equation 1. We're gonna substitute the value of TD in equation 3. So we're gonna get the value of TC, which is 36. And then we substitute this value of TC in equation 2. We're gonna get the value of TD, 124. So lastly, we got all the numbers of T in each gear, as shown in the slide. Next, we need to explain the reason to adjust the speed ratio into a real value. The gear ratio is the ratio of number of turns the output shaft input shaft turns 1. Example, if the car shifted into the higher gear, the gear ratio is through selection of proper gear ratio, torque applied to drive wheel can be multiplied. This is because transmitted power through a series gear also affect the rational speed. So the important that we need to adjust the speed ratio is we get the best transmitted power so that the gear could move smoothly and faster, also reduce any problem. That's all from us. Thank you.
Thank you.
Sekejap
Sekejap eh.
Oh, stop tak lagi.